So there are quite a few problems to do, but they're not that difficult. So again, you don't have to do the same thing as I do. Just gotta check. So you can use mine as, I guess, a point of reference just in case. So one-step equation. What did I do to both sides? So let me multiply both sides by 5. So I'm gonna go 5 times e is 5e, and 5 times 40. Ugh, big numbers, 200. Now a two-step equation, so I just created a one-step equation. Let me subtract 10 from each side, minus 10 from each side. So I'm going to get 5e minus 10. And on the other hand, on the other side, I get 200 minus 10, which is 190. So I just made a two-step equation. Parentheses, right? So what am I? So I'm going to use a GCF. So, or you don't have to use a GCF, but in this case you do actually. So I'm going to factor out the 5 out, right? So I'm going to put parentheses like this. So what number can we take out between 5 and 10? So maybe over here, I'll even do the ladder method for you. 5e minus 10. So what's in common between 5 and 10? Well, 5 is. 5 goes into 5 one time, or 1e, and 5 goes into 10 two times. So 5 is outside. 1e, I'm just going to write e, and 2. So if you do this truly properly, 5 times e is 5e, and 5 times 10, 5 times 2 is 10, right? So we're good. Now we want to add a variable to both sides, so I don't know, let's add 12e to both sides. So I'm going to go 5e minus 2 plus 12e. On this side, I'm going to go 190. Yes, I can do plus 12e, but let's do, I don't know, plus 8e plus 4e, just as an example. Okay. I don't think I'm going to do all of them. I'll probably do two more examples. That's probably enough for you guys. 33. So let's pick something. Let's divide both sides by 11. No, actually, you know what? Let's just multiply. Multiply by 2. So we're going to get 2c equals 66. Let's add 12 to both sides. So we get 2c plus 12. 66 plus 12 is 78. Parentheses. So if you think about it, I'm going to do the ladder method over here. What number does 2 and 12 have in common? 2. 2 goes into 2 one time, or 1c. And 2 goes 12 6 times. So I can change that in my 2, parentheses, c plus 6 equals 78. Add variables to both sides. Let's subtract 3e from both sides. 3c, by the way. So I get 2c plus 6 minus 3c. I'm going to subtract 3c on those sides. And the other side, I'm going to write negative c plus 78 minus 2c. Isn't negative c and negative 2c the same thing as negative 3c? So I am good. Let me do one more. Or two more. M equals 12. So I'm going to multiply by 4, both sides. I get 4m equals 48. I'm going to add 10 to both sides. So I get 4m plus 10. And I get 48 plus 10, which is 58. Now here, notice that I added 10, which is not a multiple of 4, but that's okay because they both have a common factor of 2. So if I take, look, 4m plus 10, and I do the ladder method, what number do they have in sharing common? What number can go into 4 and 10? The 2 goes. 2 goes into 4 2 times, or 2m, and 2 goes into 10 5 times. So I'm going to rewrite that as equals 58. Right? When I do this tree properly, 2 times 2 is 4, and 2 times 5 is 10. So we're good. Now we want to add a variable to both sides. I don't know, plus 8m. So I'm going to go 8m plus 2 plus 5. And on the other side, I'm going to go 58 plus 10m minus 2m. Isn't 10m minus 2m 8m? So, okay. I'll do one more. 5. This is the last one I'll do. So times 3. So 3a. 5 times 3 is 15. two-step equation. Let's add, I don't know. Let's add plus 3. So I get 3a plus 3. 15 plus 3 is 18. So I'm going to do the ladder method because I want parentheses, right? What's in common? What do they share? What number goes into 3 and 3? It's 3. 3 goes into 3 one time, or 1a. And 3 goes 3, 1. So outside is a 3. And then we get a plus 1 equals 18. Variables on both sides, I don't know, 20a. So I'm going to add 3, a plus 1 plus 20a. On the other side, I'm going to go 12a plus 18 plus 22a. Oops, plus 8a. Right? Isn't 12a and 8a 20a? Same thing, right? Okay. Yeah, that's about it. Yeah, 4 examples, and that should be plenty for you guys to use. Okay, and we'll discuss this more in detail tomorrow.